Yeah, hi everyone. I hope you all are doing good. So, in this video, we'll see how we can integrate RabbitMQ with an NestJS application. The name of this project is RabbitMQ, like I just name any project that I build. So for this, I just named it as RabbitMQ. So in this video, we will first build. I'll go over one API server, which is written in NestJS, and we will integrate it with RabbitMQ server, and we'll see how we can push messages to the RabbitMQ queues, and then we will see how we can consume or process those messages. So a rough architecture of what we will go through in this video is over here. You can see we have a RabbitMQ server running on port 5672, and the management, it's like an admin console which will be running on 15672. On the left side, this is the API server written in NestJS. We'll be running this in port 4000, and from here we will make an API call, and then from the service we will we'll push a message to the queue. And then after this much is done, we will go over to the consumer side, where we will set up an NestJS application where we'll basically be consuming the messages from the RabbitMQ server, and we'll see how it goes. So we'll first set up the RabbitMQ server, and we'll be running the server using Docker. So this is the command like docker run -d. Hostname we can give any name, and then the name hyphen name is basically the name of the container. And the port mapping is important. We have to map 5672, which is for the server, and 15672, which is basically the management console or the admin console. And then this is the name of the image, RabbitMQ :3.3 management. This management is important if we are looking for the management console. So once we run this, and it will be up and running, then we can go to the localhost 15672, and we'll see this page where we can log in. So by default, the login username password for RabbitMQ, this management console, is guest, same username password. If we click on login, you can see we will enter the application, which is for managing. Like we can create connections or channels from here, exchanges and queues. We can bind a lot of things we can do, or we can create new users over here. But for now, we'll not do anything. We just want it to be up and running. Next, we will go to the we'll start with the publisher part. So over here, this is the NestJS application that I have already set up, and I'll go over how we can connect and push messages to RabbitMQ from here. So if I have an environment variables file where I am this is the port where the application will be running on port 4000, and this is API server. So we have one route in here, and this is the messagequeue URL. Like using this through this URL, we'll be connecting to the RabbitMQ server. So you can see guest is the username and password, and then the server and the port. Then message queue exchange, we need an exchange, and the name of the queue on which we will be pushing the messages. This is the only thing we need in the environment variables. Now in the main.ts file, we are just initiating the application, nothing else. And if I go to the app.module, you can see I have a config module so that we can import the environment variables, and another module is the user module where we have just one route. Now I'll go to the user module. In fact, I'll go to the user service so that we see in the user controller. Yeah, so in this we have just one route /user, and it is for post method, and in this we have a small DTO which will take email and password. So the intent over here is in the endpoint we'll send a username and password, that is email and password, and then we'll pass this to the user service. Now it is very common that while registering a user, we capture the user information and we save it in our database, and then we send an email to the user, maybe a welcome email or something. So sending an email in the API itself can be costly because it takes time to send an email. So the response time for this API will be a bit higher. So the best thing to do is we can push the emails that we have to send into a queue, and we can send emails from a separate microservice where the microservice will pull the messages or emails or whatever you want to email, and then that microservice can send an email, and over here we can right away return the response. So something similar I'm trying to do. I'm not actually saving it in the database. So once we receive the user information, then over here we're saying, okay, RabbitMQ service push to email queue, and what do you want to push? We want to push the email address. That's it. And the microservice will pull the email address and send an email with a template or something, and we'll return the response. So in the service it looks very neat and clean. So we'll see how we can build this RabbitMQ service so that the message is pushed to the queue. So if I go to the RabbitMQ service, so in here you can see I'm using two packages. One is AMQplib, from where I'm just importing the confirm channel, and this is a very nice package. It's kind of a wrapper on top of AMQplib, which is AMQP connection manager. With this it makes us very easy to it helps in just in case our RabbitMQ server goes down, so it does not break our application. It will cache the incoming messages, and it will keep on checking if the server is up. If the server is up, once the server is up, it will push all the messages. So it's a very nice little package that I'm using here. Fine. So moving forward, over here you can see inside the constructor nothing. I'm just pulling all those environment variables, and this one is implementing on module init, so that this module is initialized only once. As soon as the application launches, we will make a connection to the RabbitMQ server. So over here on module init, we are just on module init we're just connecting. We're calling this .connect. Now in this function we can see, in this method we can see that we are using amqp.connect, and we are passing the MQ server URL. And once the connection is established, then we create a channel, and in this channel we have to pass a function, and this function is this.setupQueue, which is again at the bottom. So if we come here, so you can see that it will first check for exchange, and if there is no exchange or if there is no queue, so there is no point of keeping it running, so it will throw an error. And then over here we are declaring queue. So basically when we assert, so this application will itself create the queues and exchanges for us in the RabbitMQ server. So that's what we are trying to do. So we don't have to manually go and create exchanges and bind the queues in the RabbitMQ server through the management console. Next, we are binding the queue. So over here we just have to give the queue, exchange, and the routing key. So the routing key, I'm keeping it the same as the queue name. And once everything is set, we'll see the queue is ready to accept messages. Not just accept, it'll even for pushing the messages. Now once this is done, the connection is established. Now these two are our helper functions to push messages into the queue. Now this .channel provides us a method send to queue, where we can give the name of the queue and whatever data we want to push. And then persistent is true. Over here we are making it true because just in case our RabbitMQ server goes down and it has like hundreds of messages, and once we restart or once we start the server again, we don't want to lose those messages. So if we keep persistent as true, the messages will be persistent. So just in case if you have to restart your RabbitMQ server, you will not lose the messages. So now push to email queue, over here I'm just using push to queue, where I'm just giving the name of the queue in the text. So and this is what I'm using in the user service. You can see push to email to queue. So now the application I've already started. You can see once started says connected to RabbitMQ server, accept messages. Fine. So let's send a message. So over here you can see I'll just clear the response, and now if I send, this is localhost 4000/user post call. Once I send, I get a response as success, true. Over here it says message push to queue. If I come here, okay, I see one message is here. If I go back and I try to send few more messages, we'll see if we get those in the queue. If I come back, you can see we have 6 messages ready, but they have not yet been consumed. They're available in the queue. Now we have to set up a consumer service so that it can take the messages from there and then process it. Okay, so now this is the other this is basically the consumer service. This is a separate application. It's best to separate the consumer service out of the main application. We can implement this in the same application, but it's best to keep it separate so that you can assign resources accordingly. And if there is an issue with your consumer service, so your messages will anyhow be there in the like your main application will keep running, and you'll still keep getting the messages in the RabbitMQ server, and you can maybe fix those issues quickly, and you can then start the consumer service. So it's best to keep it separate. So in this application, we will be running this in 4001, and the environment variables are exactly the same. As I said, this is a very minimalistic application, just to demonstrate how we can integrate with RabbitMQ. So over here you can see that we are doing nothing. We're just connecting. It's listening to, it's again an app, it's connected to 4001 port. Now in the app.module, you can see we're just using config module for the environment variable, and we have one MQ module where we will be implementing the consumer service, basically to fetch the messages from the MQ. Now inside the MQ service, like it is, if you look at the structure, it still comes under source modules. So I have 2 files, module and service. So yeah, so in the MQ service, we can see we have the same package that we use there. We're using the same package, and over here we are trying to fetch the URL and email queue. Then on module init, we are trying to connect. When we connect, so over here you can see that we are creating a connection, we are creating a channel, and when we create a channel, we have to pass the function that will basically be used for consuming the messages. So this is our function, this is a method in this class. So over here I'll come to the prefetch later on. The way you can see, over there we had the function sent to the queue, but over here we have channel.consume. So when we implement channel.consume, it will keep listening to the messages from the RabbitMQ server, and as soon as a message is available, it will pull it and it will start processing it. So over here you can see we have given the queue, name of the queue, and once we get a message from the queue, we have to basically give a function here. Once we get a message from the queue, we are passing it to one function, handle email messages. So over there we are passing the channel and the message that we just received. Now if I come to this function, which is handle email messages, so in here what I'm trying to do is I'm trying to mock the kind of email response, because let's say if we are sending an email, so it will take maybe 1 second or 2 seconds it might take. So instead of actually connecting, I'm just providing a delay here, and then it'll say that email was sent successfully. Now if it was successful, we have to send channel.ack data, so that the data will be then our message will be removed from the queue. And if there is some exception, there is some error, it will send channel.nack. So in this case, the data will be requeued back into the queue for processing again. So in this case, we should handle it properly, because if there is some issue in our code, we are not handling it properly, then our messages will never get out of the queue. So it will always be a NAC. But keeping a NAC is a good thing, so that we don't lose the message just in case there is an issue because of us. Okay, so now the thing is, over here it's very simple actually. Once we get the message, we can implement our email service here, and we can just pass the message. We can send an email, and then we can send channel.ack. Now if I go back to our management console, I see we have 6 messages pending to be processed. So if I come here and if I run this application, which is kind of a microservice, start dev, so it has just started, and over here you can see we have 6 messages which was emails and sent successfully, and over here we don't have any pending message in the queue. Now this is kind of a complete implementation at the moment, but there's a small thing I want to share about prefetch, because yeah, so just in case we have hundreds and thousands of messages in the queue, and if we run this code, then we might get into some memory leakages. The reason being, we will get like 100,000 messages all at once in our consumer service, and we might not be able to, depending on the resources that we have, we might not be able to handle all those messages at once. So it's best to use channel.prefetch. So over here you'll have to adjust according to the resources that are available on the consumer service, like the amount of CPU and everything, and how much intensive is the calculation or whatever processing you're doing on the consumer service. So depending on that, you'll have to adjust how many messages it should take at once. So let's do one thing. We'll make it maybe 5, okay, and I'll just shut it down for a moment. And over here I see there are 0 messages, and we'll do one more thing. Okay, first we'll try to finish this. We'll see how prefetch works. So over here I'm trying to send we'll see how many messages. Okay, so it has 9 messages. Okay, we'll send 2 more. Oh, okay, it has 17 messages. Fine, so there were many messages that went. Fine, so there are 17 messages now. Now if 19 messages. Now if I come to the consumer service, yeah, so because we have set a prefetch of 5, so it'll fetch 5 at a time, and it will not overwhelm your consumer service. So if I run this, so we got 5, and it processed 5, then it processed next 5, so it will process 5 messages in a chunk, and it will not overwhelm or show any memory leakage issues. So it went fine. And the other very good thing I want to show about the connection manager application package, which will be from the publisher side. So now over here you can see this is our publisher, basically the API server from where we are pushing the message. So let's say that I shut down the RabbitMQ server. So I have a Docker. I'll just go to the Docker dashboard, and this is my container. So I'll just say like maybe stop. So I'm basically stopping the RabbitMQ server. Okay, so it is stopped now. Now I come here, you can see that we did not get any error message in the, now our RabbitMQ server is down, but it did not throw any error message. Now let's see what happens if we send messages. So yeah, over here you can see we are getting timeout. The reason being, I have put in await. So in here I will not put in await because I don't want it to wait. So I'll come back, and okay, so this is fine. And I think this is not a bad idea here, because even with await, if you put await, we'll still be giving some kind of lag in the response. So I think it's okay if we remove await here. And the benefit of this package, the connection manager package, is that the messages are like, we have 5 messages here. The messages have been cached, so our application is running fine and our messages are safe. Now if I go back, if I come to over here, so the server is down. If I come back and I start this server, okay, and over here you'll see once the server starts, okay, now you can see automatically it said that queue is ready, and it pushed the messages on its own. So this is a very nice thing from that, because if we don't use that package, we have to handle these things on our own. And now if we come here, so the message has already been consumed. If I go to the consumer part, so the message was already consumed. Okay, so yeah, so this is it in this video. I will be pushing both these packages in my GitHub repo, and I'll share the link in the description. And yeah, thank you so much.